In this video, we will be graphing logarithmic functions. An important thing to know about logarithmic functions is that they are inverses of exponential functions. So because y equals b to the x and y equals log base b of x are inverse functions, we know that their graphs will be symmetric with respect to the line y equals x. We can see a good example of that in this graph of f of x equals 2 to the x and f inverse of x equals log base 2 of x. So if the exponential had base 2, then the logarithmic function will be base 2. Notice that the symmetry is over the line y equals x, meaning that the two graphs are mirror images across that line y equals x. All of the ordered pairs, the xy ordered pairs on y equals 2 to the x, swapped the x and the y to give us points on y equals log base 2 of x. Since the graph of an exponential function has a horizontal asymptote, a horizontal line that the graph approaches but never touches, the graph of a logarithmic function will have a vertical asymptote. That will be a vertical line that the logarithmic graph approaches but never touches. Let's get some practice actually graphing some logarithmic functions. So the first one says graph the following logarithmic functions. To do this, plot 2 points on the graph of the function and also draw the asymptote. Now, it's okay if you get more than 2 points. That will just improve the accuracy of your graph. Then connect the points. Additionally, give the domain and range of the function. Now, the vertical asymptote is always going to occur when the expression plugged into the logarithm equals 0. We call that the argument. So in this case, we would look at our function for log base 1/3 of x. X is called the argument. And the vertical asymptote occurs when the argument equals 0. And that's always going to be the case. You won't always just have an x plugged into your log, but whatever that expression is, you want to set that equal to 0. So in this case, our vertical asymptote is at x equals 0. And we want to go ahead and graph that with a dotted line. So that's what I would do first, is go ahead and graph that vertical asymptote. So I'm going to grab my line. I want it to be a dotted line when I'm doing an asymptote. And then I'll just go ahead and make that vertical dotted line at x equals 0 in this case. So there's our vertical asymptote. Right on the y-axis. All right, so now what I want to do is I want to plot my points. And when I'm trying to plot my points, what I want to do is change my logarithmic function to an exponential function, because we know how to work with exponential functions. So what I would do is I would rewrite my function as y equals 4 log base 1/3 of x. And then I would get the log by itself. So I'm going to rewrite this as y over 4, dividing both sides by 4, equals log base 1/3 of x. And then we learned previously that to rewrite a log in exponential form, we take the base, we raise it to the power on the other side of the equal sign, and that would equal the argument of the log, so whatever's plugged into the log. So what I would get here is I would get 1/3 raised to the y/4 power is equal to x. Now I'm going to use this rule to figure out points on my graph. So instead of picking x values like I usually do when I'm plotting points, I'm going to actually pick y values. So I might say let y equal 0. Then I'll plug that into the exponential function that I figured out here. Then x is going to equal 1/3 to the 0/4. And 0/4 is just 0. So that's actually just 1/3 to the 0 power. And we know anything to the 0 power is 1. So now our ordered pair, x is 1 and y is 0. So that's going to be one of my points. I have x is 1, y is 0. And now I need a second point. So I'll pick another y value. I'm going to go ahead and let y equal 4, just so I get a whole number exponent. Then x is going to equal 1/3 to the 4/4. So that's really just 1/3 to the first power, which is just 1/3. So 0.33 if I was putting that in. And so my point is going to be 0.33 or 1/3, comma 4. So when x is just 1/3, the y is 4. So I'll go ahead and plot that point. Now I could go ahead and draw the curve at this point, but it wouldn't be very accurate. I'm going to go ahead and get a third point just to help myself out here. So I'll go ahead and let y equal a -4 now. So I'm picking a number that will still give me a whole number exponent, but I'm actually going to get a negative exponent. So if y is -4, then I'll get x equals 1/3 to the -4/4 using this exponential form that I found. And that's going to be 1/3 to the -1, which is actually equal to 3. So another point on my graph will be x equals 3, y equals -4. So here's 3, -4 on the graph. And because I'm plotting by hand, I might actually go ahead and just get one more point. So I'll let y equal -8, again, so that I have a whole number exponent here. So x will be 1/3 to the -8/4. So that's 1/3 to the -2, which would be 3 squared, which is 9. So I have one more point, x is 9, y is -8. So that will just help me with my accuracy on plotting my graph. So I have when x is 9, y is -8. And I can go ahead and connect those now. My graph should go almost up against that vertical asymptote, but not actually touch it. And then smoothly connect these points. and I've got the graph of my logarithmic function. So there's my graph. To find the domain and the range, you would just look at, for the domain, you're looking at all the x values. So the domain here you can see is from x equals 0, not including 0, up to infinity. So I would go ahead and say my domain is 0 to infinity with a parentheses because I'm not including 0. And then the range, if you look at the range of that graph, all the y values, it's all real numbers. So I would do negative infinity to positive infinity. I want to do one more example of graphing a logarithmic, but I'm going to do it in the next video.